I would like to say thanks again to the Universitat Pompeu Fabra, MTG, and all the companies supporting this event. And a special thanks to all of you. It's a great pleasure having you all here. I see some familiar faces, so some of you, it's not the first time that you come to this event. So hope you have a great 24 hours of work, and you can afterwards enjoy the Congress, and of course enjoy the rest of the music concerts that we have outside here. So please mingle with everyone, try to know as many as creators, musicians, because they really need your help improving their work. So thanks again for being here, and I hope you had a fantastic time.
Hi, I'm thanks. I'm Sergi Jorda from the Music Technology Group. I guess I know several of you, so probably several of you know me also. As Ventura has said, we are very happy that you are all here. This is the 6th edition of the Music Hack Day and the 5th that happens, the 6th organized by the Music Technology Group of Universitat Pompeu Fabra, and the 5th in collaboration with Sonar, which I think it's a great joint. It's a great pleasure to be able to do this event here. As Ventura has said, I see many known places, so it's good that people come back year after year. This year, the topic will be focused on wearables and music performance. And I'm sure we are going to see really exciting hacks on that. I would like to thank a lot of people, all the people at the Music Technology Group that has worked for organizing that, Alba, Sebas, Panos, and a lot of volunteers, all the sponsors, obviously Sonar, without them that couldn't be possible. So I just give the turn to Sebas and Panos, who will give you a bit more details about the organization of this event. So thank you very much for being here, and we hope you will enjoy it very much.
Thank you, Sergi and Ventura. Well, we welcome you to the 6th edition of the Barcelona Music Hack Day. So as Sergi and Ventura were commenting, you will find several of us in red t-shirts. So we are the people that is willing to help you, the organizers. So you have Alvaro, Frederic, Alba, Panos and myself, Tom, a lot of volunteers this year. So we are very happy to have them among us. So let us, we would like to have 5 minutes of your time to share with you some highlights about this edition. So, as I said before, this is our visual identity this year. So this is what you have on your t-shirts, in our t-shirts as well. So there are a couple of remarkable things that you should know. This year, the Music Hack Day is supported by 2 European projects. One of them is Music Bricks, which is the one organized the workshop on music processing yesterday at Hangar. So you will have also the music brick technologies available for hacking. So you will see the organizers of the workshop around you. So if you have any question, you can ask them. Also, they are going to give a prize on the best hack using the music brick tools. And this is going to be an incubation program. On the other hand, we also have the Rapid Mix European project, also responsible for the workshop of wearable technology for music performance that we had yesterday at Hangar. So Mick, Rebecca, Hugo, they are among you. So if you have any questions, if you are willing to use the Rapid Mix technologies, you can ask them. Also the Rolly guys. And they are also going to run some user-centered design studies. So if you find some of the Rapid Mixers asking for an interview, just be good with them. That will be very helpful, and say yes. And then we are also going to give a prize from Rapid Mix, which is basically for the best hack using wearable technology for music performance. So we have actually 12 prizes this year. If you go to the website of the Music Hack Day, in the section prizes, you have a list of all the challenges and prizes that we have for this edition. So just go through it so you will be updated about that. And as Sergi was commenting before, we have a special track on wearable and music performance this year, so we are going to be pushing the idea of making music with technology for wearable computing, so keep it on mind. And finally, one of our main sponsors, Reactable System, is hiring. So probably you sign up for a form at the entrance, and if you have any question or if you are interested on Reactable and their offers, you can go to the booth, which is at the right of my right of the stage. So let's keep going.
All right, so regarding the internet connection, you can see that you have Ethernet cables in the tables, so you can connect wired. And then for wireless connections, you have like some papers here and there on the registration desk as well. Now for regarding social media things, we have a Flickr group, so when you upload photos and stuff like that, please tag them with the hashtags Music Hack Day Barcelona in 2015. You can also, on Twitter, you can use Music Hack Day and BCN Music Hack Day. And also we have a Facebook group, which is Music Hack Day. Then, now we will start soon, we will start the presentation of all the technologies that are presented and the hacking tools. So basically, every technology presenter is going to have 5 minutes to present their tools. The schedule is available on the website. If you go to program, I can show you maybe here. So if you go to program, then go to day 2, and then click on technology presentations. Here you will find the list of all the technologies. Okay. And then finally, of course, all the technology evangelists and representatives from the technologies are going to be here during the hackathon. So whenever you need their help or advice, or you want to show something cool that you are making, etc., please contact them and talk with them. Yeah, regarding the Hacker League, so everyone who wants to submit a hack has to make an account on Hacker League. So all the participants should, by the time they submit the hack, make their account. And then we have a submission system ready for the hack. So as soon as you're ready, you just put it there. And keep in mind that the order of presentations of the hacks will not be the same as the order in which they appear in Hacker League. Okay? And of course, as you can see, we have some cameras over there. We are real-time streaming this part now, as well as the hack presentations at the end of the hackathon. And we will also have the First Vision T-shirt with the camera and the biometric sensors, etc., also capturing video around the event, which we'll be using later. So yeah, if you guys want to start coming towards the front now so we can have a small crowd for the presentation, that would be great. Okay, so back to Sebas.
Yeah, so finally, while we are waiting for the presenters to start the technology presentations, we would like to thank our sponsors, the companies and the people that make the Music Hack Day possible here at Barcelona. So Reactable System, Technio, Deezer, Ableton, and the European Commission. Also, we have a group of very supportive like prize session sponsors like Music Match, Native Instruments, SoundCloud, StarLab, and then collaborators like Angar, and Non-New Folk Studio, sorry, I forgot. And collaborators that help us with the pre-event organization like Angar, amazing people. We are very lucky to have them, and Fonos Foundation for all the technical support. So we are moving now to the presentations of hacking tools. So, and we are going to start with acoustic brains. So I think Alastair is going to be the first one.
I guess that's what we get for naming our project alphabetically starting with A, yeah? Full screen, I guess. Oh, is it that kind of full screen? Okay. Let's start. So I'm Alistair. I work on a project called Acoustic Brains. Acoustic Brains is a crowdsourced database of music features. If anyone here knows the Echo Nest, for example, we are kind of similar to the Echo Nest. We have all these features for a lot of audio. The big thing that makes us different is all of our data is completely free. We have open algorithms. We use some software called Essentia, which is developed here in Barcelona at the Music Technology Group. Essentia is GPL licensed. All of the algorithms and all of the source code is free. All of the data that we publish is completely free, Creative Commons licensed. We have 2.5 million tracks of audio features. So if you want audio features, you should come and talk to us. We have a lot of data extracted from a lot of state-of-the-art algorithms, MIR algorithms. We can give you beat information, the BPM of a song, where all the beats occur in a song. We can tell you what key the song is in, whether it's major or minor. We can tell you information about the chords. We do a lot of sort of more low-level researchy stuff. If you're interested in MFCCs or spectra or loudness or energy, that kind of stuff, we also have that. We do a bunch of machine learning on top of this, and we can tell you other stuff about the music based on its content. We can tell you what the genre is. We can tell you if it's happy or sad, if you can dance to it, if it's got a vocalist, if the vocalist is a male or a female. It's really easy to use. You get a MusicBrainz ID. You go to musicbrainz.org. You download a client library for your favorite programming language, search for someone, get a MusicBrainz ID for a recording. We have a URL here, and that'll give you back JSON containing all of the information you need. Really quickly, I'm going to ask everybody also to help us. If you have MP3 files, if they have MusicBrainz IDs in them, you can submit all of this information back to Acoustic Brains and help make Acoustic Brains better. So I really ask that anyone who has MP3 files from, maybe you got MP3 files from the internet, maybe, or you bought CDs. It'd be really cool if you could help and contribute, especially if your music's maybe a little bit rare. We want to get as much music information as we can. We have a Twitter account at Acoustic Brains if you want to follow us and get more information. We have a website, we have a blog, so any questions, come and see me afterwards. Thanks.
Okay, well, thanks a lot, Alistair and Acoustic Brains. And now we have the guys from Vastly. So take it away.
So, hello hackers, my name is Gustavo, I'm from Vastly. I've been in your position many times. I love hackathons, I'm a developer myself. So, is this in auto? I cannot see the screen. It's going forward without. Okay. So, we have prices, so pay attention. We will say what prices are afterwards. So what we do is a real-time way to connect your apps. We are the string that can connect your apps. It could actually save you 10 hours in a hackathon or 12 hours, depending what you want to do. So what we do is actually we publish in real-time data from anything to anything. In this is suppose you have an Arduino, a Makey, or anything that you want to send to your Android. So you can, Vastly, you can do it easily. Another sort of communication, if you have Android devices, web browsers, or servers, and you want to send messages between all of them, and without setting up your infrastructure, nor servers, nor anything, we take care of all that. So installing is really easy. In the front end, you have Power installs Vastly. If you have a server with Node.js, you can start with npm. We have also an Android library. And to get an API key, you just go to vastly.com/mht, and you can get your API key to use. So let's see how to actually use it. This is how you will use it in JavaScript. You just say the name of your user is Alice, your API key, and what you want to do with the data that comes back. And to send data, it's only Vastly.send Bob a message. You can send any JSON object. And you can subscribe to other channels. So that's all you have to do to send any information from a web browser to an Android. So think about the time that you will save if you use something like us. We have also the Android library that is the same, your device ID, your API key, and who processes your messages, and what sort of class you want to send between the devices. This is also the implementation for receiving messages or for sending messages. It's all very tied up to each platform idiosyncrasies. And also, if you don't have a library or you want to send you can only connect through a REST API, you can call our library through a REST API, sending the same data. Your API key, your data, where you're from, and to. So to showcase some sort of what we do, if you could please go to bastly.com/key, we will all play at the same time a musical keyboard. So if we wait for a second and we go there, and you can start pressing keys whenever you want. It's going to be a mess because there are too many people playing, but let me see if I can do it here. So this is now it's off. And the presentation. So that actually took me like 10 minutes. I got the keyboard from somebody, and now we can play all together the keyboard with only 10 minutes of things. Another demo that we have is we also have a library for wearables. Since it's a wearable thing, we also have the library for the wearable for you to use it directly. So if you go to bastly.com/sonar, I don't want to put it on the thing again, but I don't know if you have it there. I move the wearable, and it will start making sounds. People are playing the piano still. Well, but we have also a library. If anybody would open up that Sonar, you also have a Sonar, a wearable library. Everything we do is open source. So we have in our GitHub, we have the demos for bootstrapping. You will save tons of time. The documentation is also on our webpage. And if you sign up with MHD demo, it will be quicker. So this is our prize for the best hack using our technology, an Novation Launchpad controller. That's a really cool thing to play afterwards. And we're both in yellow, we're both developer, we're willing to help with our technology or with any other thing that you needed. We will be all day here and also understand there downwards. Thank you.
Thank you. So now is the turn of BBC. Sarah?
Thank you. Good morning, everyone. That is presentation mode. Loading. Okay, so I suppose that a lot of people knows BBC, but most of you maybe don't know that. Most of you maybe don't know that we have APIs and you actually can use our data. So, well, this is for the API key. If you want to use it, just speak with me and I will give you a key if the system works. So we have Nitro, and Nitro basically controls like all the programs, all the schedules. If you want, for example, a specific program you want to know about, I don't know, it's enders of Top Gear, we could give you like all the information and all the music that has been played in Top Gear in the last month, for example. Radio 1, we could give you all the schedules for Radio 1 for the next week or whatever. You could get all the music that has been played, all the playlists. So that is Nitro. There is also like documentation online. If you go to developer.bbc.co.uk, you can find all the information there. But we also have a new project called BBC Music, and we have all the records that has been playing at the BBC. We have all the information, 30 seconds snippets, and how many times has been played, in which service, when was the last time. You also can have all the artist information, all the info is coming from Music Brains. We have the now playing service. So for example, if you want to know what is playing right now in Radio 1, you could know that. And you could also know what has been played recently. So if you want to know the last 10 tracks that has been played in Radio 1 or in Radio 2, you could know that. Come on. Okay, and we also have playlists. We have a new service called BBC Music Playlister, and we have a lot of playlists. Some of them are in Spotify, some of them are in Deezer, but all of them are at the BBC. And you could get all the playlists and links to partners. So for example, if you have a track and you want to know the ID in Spotify or Deezer, we actually have the matching done, so you could get that. And we also have BBC Introducing, that is basically new bands. So you could get the new bands that has been played at the BBC in the last month in specific programs. So that's it. It's your turn. Let me know. I'm going to be right there doing hacking, hardware hacking with Rob. So if you are interested and you want to know more, just let me know. Thank you.
All right, so thanks a lot, Sarah and the BBC. So now we have the presentation from Deezer. And after that, Music's Match should start getting prepared. Okay, so.
Hello. Hi. So my name is Louis. I'm very excited to be here with you. So some of you might know Deezer, some not. To give you a quick presentation, Deezer is a global music streaming service. Very quickly, a few numbers. Deezer is a catalog of 40 million tracks, one of the largest catalogs in the world. We have 16 million monthly active users, more than 100 million playlists already created. We have an editorial section that is human-based content, and recommendation that is algorithm music selections. We're available in more than 180 countries around the world, on most continents. So to go quickly, Deezer's platform. It's a REST API. We have 3 SDK, iOS, Android, JavaScript. Online on the developers.deezer.com portal, you can find all the full documentation and UX and UI guidelines. And you can just start streaming music with those SDKs. So our API, you can access our search engine. You can search for any tracks, artists, user, albums that we have on our website and on our apps. You can even go up, look at the user's listening history for a few months back. You can search for playlists, editorial, and you can also access Flow, which is our recommendation feature. It's a personal radio based on the user's listening history. That's a great feature to use. 3 things our SDKs are great to use. It's for authentication, really easy. You don't have to use your own forms. Streaming music, you have to use our SDK to stream full track music. And of course, SDK is a wrapper of our API. We have a small web app demo that you can use. It's deezer.com app/demo. It's based on our SDK JavaScript. All our apps that you do with our SDK can be used outside on a standalone application or can be used inside Deezer ecosystem. To show you, we have an app studio where we feature our best applications that were made by third-party developers. You can push your application into that ecosystem and control Deezer's website from there, or mobile application. So just to show you how you can start, the key features. The API is RESTful, so HTTP request, output in JSON, XML, or JSON-P. The architecture is pretty common with, we're inspired by Facebook architecture. So if you're used to using Facebook API, you will recognize the authentication flow and the permission management tool. Very easy on the developers portal, you can use the API Explorer. It's a great way to start playing with our API. And we also have samples available for mobile development. So to start, go to the website developer.deezer.com, create an app ID, an application, select the SDK you need for your hacking, and go to the API Explorer to learn how to use our API. We have guidelines and some UI, UX guidelines, but I'm not sure you won't need that for your hacking project. A little showcase of what has been done already. Les Inrocks, a French great music magazine. They have their own custom player, so they stream music directly from Deezer. HousePL, a small player banner on the bottom. Shuffler FM, this is a good example of what you can do. It's a standalone created audio magazine, but it's also available inside Deezer ecosystem. Great way to showcase your app. And we also support a lot of music festival applications, such as Sonar for 2015. If you look at the app, you can play Deezer music directly from the app. Our prize is a 1-year free Premium Plus subscription to Deezer for all the members of the winning team. Deezer is always looking for computer engineers of any type. So if you're looking for a job or anything, come check us out. And just to finish, I'm really excited to be here. It's going to be awesome. If you are hacking with Deezer, please come see us. We'll be sitting at the first table just over there. If you just want to talk or you need some help on anything, just come see me. Thank you.
Thank you. So now is the turn of Music Match. Next one is SoundCloud. So please come close to the stage. Es que estamos mareando mucho a la gente.
Que vengan a presentar a la Club Melodías. Yo estaba conectado.
Thank you. I'm Varun. Hi, I'm Varun. I work at a company called Music Match. Hi, sorry for the delay. I'm Varun. I work at a company called Music Match. Before starting the presentation, this is my 4th year at the Barcelona Hack Day here. So thanks to the organizers for doing this every year. Just a question. How many of you use Music Match or know about the company, have the app installed? Okay, not so many. So I'll just play a short video which will give you a good idea of what we do.
Wiggle, wiggle, wiggle. Wiggle, wiggle, wiggle. Just a little bit of patty cake with no hands. Got me in this club making wedding Cadillac, pop that trunk. Let's take a shot, alley-oop that dunk. You act so innocent now, but you lied so soon. When I met you in the summer.
If you gave me a chance, I would take it. Knowing through the heart, you can't shame me when I am with you. There's no place I'd rather be. No place I'd rather be. When I'm with you, there's no place I'd rather be.
If you like that, please install the app. So as you must have understood, we have a very large database of lyrics, and the lyrics are also synced in time to the audio. We have apps for all the platforms you can imagine, and also we have a lyrics website which was launched recently. As far as the hack day goes, our API is a RESTful API, and we have functions to give you the lyrics for any song. We have a search, we have the search for getting the subtitles, and also getting a lot of other metadata. And if you want to use the API, you will need an API key. So the API key is kind of long, so just come and find me here and I will help you out with the API. And if you go to this link, there are some recent hacks that we did with the API at various hack days. And okay, and if you use the Music Match API, and if I like it, then there's also a prize, which is a Korg synthesizer, a small one. So that is my presentation, and thank you.
Okay. All right, so thanks a lot, Varun and Music Match. Now we have Tingwei from SoundCloud who's going to talk about their API, etc. So here you go.
Thanks. Hi, everyone. I gotta log in. Hi, so I'm Qingwei. I'm from SoundCloud. Very happy to be back at Barcelona Music Hack Day. Here to talk about the SoundCloud API. So SoundCloud is the home of over 100 million tracks that span everything from major label releases to popular artists and indie artists, DJs, individual uploaders who just upload sounds, and radio shows, podcasts, all kinds of different content live on the platform. And we have over 200 million listeners every month who come to SoundCloud and listen to our stuff, which is open and embeddable through any website. We are actually, our creators upload 12 hours of music every minute. So while I'm talking here, we're probably getting another 12 hours of audio uploaded to SoundCloud. So I wanted to start today off with a little audience participation. So I'm gonna just, connect with SoundCloud. I'm gonna do a little recording from the browser and upload it to SoundCloud. So if I can get everybody to join in, it's early in the morning, it's a big place. Can we say, on 1, 2, 3, we say hola, okay? And we'll record that and we'll put it on SoundCloud. So let's see, let's start now. Okay, 1, 2, 3. Hola! Thank you. All right, so that's gonna upload. It's there. It takes anywhere from 1 second to 10 seconds to transcode. I'm just gonna go ahead with the presentation for now, and we'll check on it later. So we have an API. You can go to developers.soundcloud.com and everything you need is there. So the first thing you'll be wondering, how do I get a key? You can go to developers.soundcloud.com and register a new app. And I can say my app here. Click here and register. And there we go. I have my client ID right here, client secret, and you're good to go. So it's just 2 clicks. You get an API key. Let's see. You can also find documentation about all our APIs. We have a kind of a getting started guide here, the API reference, and information about our wrapper SDKs. So developers.soundcloud.com. We have 3 SDKs, Ruby, JavaScript, and Python, and it's all built on top of a RESTful API. So if there are platforms that aren't supported by these, you can talk directly to the RESTful API and do everything that all these SDKs can. I'm going to do a couple of demos with the JavaScript SDK. Simplest one, how do I play music? How do I play tracks from SoundCloud? So I made a really simple text box and a search button. Let me show you the code here. It's literally 4 lines of code, 4 steps. The first step, you just include the SDK. That's as easy as script source, this hosted SDK. And then you do sc.initialize with your client ID to initialize the SDK. And once you're there, you can start using the SDK. What I'm going to do here is take the click event and search for tracks. So this line sc.get is the important one here, and I'm saying get from tracks with a query of some string, and it's going to call back this function. And the 4th step, once I have the tracks, is I just embed. There's an HTML5 player that's embeddable within any web page. So if I, for example, I didn't want to do that. Okay, so if I do Music Hack Day, see what we get. Oh, look, Music Hack Day. Let's see what it is.
Music.
Music.
With hack.
Hack.
Day.
Day.
Yeah, a little quiet, but it's somebody saying Music Hack Day. So there you go. It's not all music. We have all kinds of stuff. 100 million tracks is, yeah. So that's how you play a track. You can also search for playlists. Everything's exactly the same. Instead of doing your get on the tracks endpoint, you do a get on the playlists endpoint. With a text query, I'm going to query for Sonar Barcelona. And what do we get? We get, hey, the Sonar Festival from 2014. Who's on top? Like I didn't see a 2015 yet, but maybe later. Cool. I said I would step back to the record example that I did in the beginning. So this is actually brand new. If anyone's tried to do uploading from our JavaScript SDK before, you might have run into a certain Flash issue, as in you had to use Flash. I have some code here. It's not baked into the SDK yet, but come look for me if you want to do uploading from the browser. So I'm using awesome HTML5 WebRTC to record from the browser, and then just passing that straight along to the RESTful API through JavaScript. That's how I did that upload before. So just in summary, go to developers.soundcloud.com or look for me with the SoundCloud t-shirt if you have any questions about using our API. We are happy to give a 1-year SoundCloud Pro Unlimited account to the best use of our API. And with this, you get unlimited uploads and you get stats, so you can see who's listening, how many people are listening to your uploads. You can customize your profile page and stuff like that. And if you have any questions, you can find me in real life or on Twitter or by email. And let's check in on that recording we did earlier. Let's see. Oh, come on. Yeah. I think because I went back. Can we do hola again? 1, 2, 3. Hola! All right, let's see. And is this gonna work? All right, it takes, like I said, a little second to read. Hola! There we go, it's there. All right, cool. Thanks, everyone.
Thanks, Chingwei. And now is the turn of hashtag Music Bricks. So all the crew from Music Bricks on the stage, please. There you go. Woo.
We have one fan. Okay. Hello, Music Hack Day. My name is Cyril, and I'm here to present Music Bricks. Whoa, whoa. Music Bricks is it's coming. So it's a project, it's a European project that you're gonna see now on the screen. You have flyers. They explain what are the different bricks. So each brick is a technology we have here for you guys to try and to play with. You also have stickers you can use, it's for you. And I'm gonna give you more details about the project. So it's a European project, Horizon 2020 project. It groups 6 European partners, and we are collaborating here today. What we do is we give you tools, we give you new things, from melody extraction to motion sensor to rhythm, onset description for you to play with. And what we want you to do is to come up with like new ideas. We are looking for creative ideas, innovative ideas, and we want to support hackers to the next level. So that's what we call the incubation program. The incubation program is an award to promising hacks, and we're gonna give you support, which will be in terms of funding, but also support from the team of the research centers. And you will have the money to make your hack maybe a prototype for a product. So it's going to be funding for you to travel, to buy material, and for you to work on this project. So we are going now to present the different technology we have as bricks. You can have all of them here. You can also ask me or any other member of the crew. And we strongly encourage you to apply to the Music Bricks incubation program, because that's a great opportunity for you to get some funding, and if you want to go to something maybe that would be a product in the future. So it's very simple. You just go to this URL, bit.ly Music Bricks, to see the tools, and the same, but Music Bricks Award, to know about the incubation program. Just have to fill a form. So to participate, you just have to use one of the bricks that you're gonna see here, and it's better if it has a commercial potential. And we are very looking forward to what you're gonna be doing. So now I'm gonna switch to UPF with Nadine. She's gonna talk about the first brick.
Hi. So the first thing we would like to encourage you working with is our Essentia library. It's basically a library written in C++, which also provides Python bindings for extracting all types of descriptors from audio. So from very low-level MFCCs, RMS, to very high-level rhythmic, harmonic, etc. And in particular, we've been working lately on melody extraction algorithms. So you have some algorithms for extracting pitch contour from different types of signals, and also to get like a MIDI-like transcription from an audio file. And we, on the website essentia.upf.edu or via the Music Bricks page, you will find some information, some examples. We also have a new, in Essentia, a real-time module for onset detection and onset description. So you do not only get the onsets, you also get some information about them. And all of that is implemented as an external for Pure Data and Max MSP. And we also would like to encourage you to work with the Freesound API. Freesound is a very large collection, collaborative collection of sound files, sound samples, so not only music, but also everyday sounds and synthetic sounds. And you can not only use them for your hacks, but we also provide an API where you can apply various types of searches. You can search by jail tag, you can get information about the users. And if you have any questions about any of our technology, we have here Jordi and Dimitri and myself. And also for Freesound, the expert is Frederick, who's hiding at the moment. But yes, ask us if you need any support during your hacks. Okay, thank you.
Okay, hello everyone. I hope you found those stickers on the tables. They resemble the bricks. You can stick them anywhere you want. I'm Thomas Liedi from Vienna University of Technology. We provide another music brick for rhythm and timbre analysis. I'm gonna say briefly what it can do for you. So with this music brick, it's a library for analyzing audio and getting rhythmic patterns out of the audio, rhythm histograms and spectral descriptors, which describe the content of the music in rhythm and timbre. So what can you do with it? You see it on the pictures a little bit already. You see clearly the rhythm of the song in the spectrogram. So it would enable you to identify which genre a piece of music has or to find similar sounding songs. So this library, you can load audio files from disk, or you can get live audio into this library to process it. We provide it for Python, Java, and MATLAB. You can download it for free from this website. There's also the tools website in the end. And yeah, basically you can do a lot of things with it, find similar songs, create playlists, detect the genre. I'm here to help you on any idea you have. And then in addition to that, we also have a web API that's called Search by Sound. It's a REST API that does a similar thing. You can actually upload a song or use the pre-analyzed database to find similar sounding songs. So it's matching once again by rhythm or timbre. But in this case, you don't need to install any library. You don't need to install anything on your computer. You just use this REST API in whatever programming environment you prefer. And it's a super fast analysis. So once the song is up in the database, the analysis of a full song takes about 1 to 2 seconds. Once again, the URL here. And this is a web front end that's also linked on that website. So you can try it as a preview to search for songs. And in this waveform preview, you can mark a segment and it would search the entire music database for segments in any songs matching that segment you selected. So you can search for a specific guitar riff for a certain mood in music. Okay, that's it from my side. And here is Jakob from Fraunhofer.
Okay, hello everybody. My name is Jakob Appesser from Fraunhofer IDMT in Germany. And we provided 2 different bricks, which I'm gonna just briefly present. So the first brick is our Music Bricks transcriber tool. The idea is that you can use it as an offline tool to analyze audio files in WAV and MP3 format. The tool can extract both the melody and the bass line of a song. And it can also provide information about the key. So, for instance, if the song is in C minor or E major, you get information about the temporal positions of the beats, so the beat times and numbers, and also an estimate of the average tempo in BPM. The analysis results are provided in different output formats like MIDI, Music XML, or plain XML. And maybe as an addition, we also provide a Python wrapper to load these XML results and to use them in Python data structures. The second brick is a tool for real-time pitch detection, which allows to analyze continuous audio, so audio sample blocks. And the algorithm detects the currently played pitches. And there are different, there are 2 different modes. One is the monophonic mode, which can transcribe the predominant melody. So here you get an estimate of the note pitches, but also of the precise fundamental frequency, which can be interesting if you want to look at how well the tuning of a performance is. And there's a second mode, which is the polyphonic mode, and this provides a number of note pitches, like if you have chords played on a piano, for instance. So the polyphonic mode is an informed algorithm. That means it's not just transcribing audio as it is, but you have to define a certain reference pitch, which allows the algorithm to get an idea of what's the pitch range it has to search in. And the real-time pitch detection is provided as a C++ library. And it also includes sample projects for all platforms, Windows, Mac, Linux, but also for mobile applications like in Android and iOS. And these sample projects should be a good starting point if you want to use our tools. So I'm here all the time, so I'm happy to help if you have any questions. Okay, thanks.
Good morning, everyone. So I'm Emmanuel from Aircam Paris, along with Frederic, and we are presenting today another brick, which is a combination of a hardware brick called Riot, which is a small Wi-Fi transmitter combined with a 9-axis RMU that is appearing now. So this little thing is streaming the sensor of a Wi-Fi as an open sound control data flux. And we're also providing a set of tools for MaxMSP to analyze the motion flow and turn it into a musical controller. So the sensor analysis has a few motion classes that are detected, such as the kick detection, as opposed to shaking or non-moving or free-falling. So you can throw the module in the air and it will detect that the module is falling, which is obviously a different gesture or motion compared to shaking or something else, or spinning, for instance. So this goes along with a set of a Max MSP objects, externals, abstraction collection, and all that can be found on the Music Bricks webpage, on which we provide the links.
Just one thing, if you don't use Max MSP, I mean, the data is streamed using OSC, so you can get the raw data with any application that use OSC.
So one last thing, this is a sort of limited resource as we proposed those during the workshop yesterday. So I think we have about 5 left. So first come, serve, I would say. Thank you.
All right, so that's the music breaks. Check the flyer, come to us, ask us, and please try to submit to the incubation program because it's a great opportunity for everyone. So thank you.
All right, so thanks Cyril and Music Bricks. So now we're going to take a little break until 12 o'clock where we will continue with the presentations. And yeah, so see you in around 10 minutes.
who's working on Juice, which is a product of Rolly as well. If you don't know us, we make this expressive instrument called the Seaboard Grand, which you can have a look at here. So that's the Seaboard Grand. We've got 2 of them here for you to hack with. It's basically an incredibly expensive, sensitive sensor array where we can get per finger velocity, pressure, and pitch bend. And we have APIs for processing, Cinder, MaxMSP, Objective-C, Python, anything you'd want really to access all of this data and put it wherever you like. So come and check us out. We're just over there if you want to use the Seaboard for any hacks today and tomorrow. Also, we have a prize, €150 Toman voucher for the best Seaboard hack.
So I'm also from Rolly. I'm here for Juice. So Rolly acquired Juice last year. And for those of you who don't know Juice, Juice is a C++ audio framework. It's the fastest one out there. It's used by very, very many companies. MaxMSP is written in Juice. Korg uses it. Akai uses it. Traction is completely programmed in Juice. Fruity Loops, older versions used to be programmed with Juice. So yeah, it's a very, very professional, high-performance C++ library that supports all the plugin formats, MIDI, network, GUI elements, everything you want, OpenGL. What? And yeah, it's multi-platform. So Android, iOS, Mac, Windows. We're sitting over there, so if you want to get started hacking with Juice, you can come see us. We'll point you in the right directions. And also there's the Juice €150 Toman voucher for the best Juice hack that you come up with. So looking forward to seeing your hacks.
All right, so thanks Felix and Fabian. Now we have Hugo Silva from Plax who will talk about Vitalino.
Hey guys, good morning. So I'm here with Vitalino, which is a rapid prototyping toolkit, kind of like the Arduino for your biosignals. Basically, we started by looking at how the do-it-yourself community evolved, and as you know, the Arduino as the precursor has completely exploded to a number of platforms for wearable prototyping and a number of things. And when we look at what people are doing with these things, it's absolutely amazing. So this was a project of a flamethrower pumpkin for Halloween, where kids would go and ask for trick-or-treating, and it would trigger off the flamethrower, a project which someone did just for fun, like a hack that you can do today. Then we have things like this, Back to the Future sneakers, that detects whenever the person puts the foot inside the shoe, and ties the laces automatically. And the fun part of it is that it started as a hobby, and now it's said that Nike this year will launch a commercial product based on this prototype, okay? And then we have like other ideas that are based on do-it-yourself hardware, like this little aquatic drone, which started its life as a Raspberry Pi and is now a commercial product that the original hackers are profiting from. And what we saw, and the motivation for Vitalino, was that this space was severely lacking tools for body signal monitoring. So body signals are normally seen as things that live in a hospital, things that have very difficult setups, and we packed all of the main parameters like muscle, heart, nervous system, and everything in a small little board that you can use off the shelf. It has Bluetooth connectivity, power, its own microcontroller, and you can basically create anything that you want with this tool using your own body signals, making things more organic. We also made it as a Lego, so you can break stuff apart, recombine it, create really small and compact devices from it. There's free software as well that enables you on one hand to look at your signals. If you don't like to see electronics exposed, you can go to our website and download models and 3D print them to put the electronics inside, and you have a number of them. And then you have a whole different range of projects that you can do. I have a few examples here, like a drone controller that uses your muscles and motion to activate the drone and control its movement. A door lock that is triggered by your muscles, so whenever you clench your arm, the door lock unlocks. A steering wheel of a car that measures your vitals, and a number of other parameters. So Bitalino is now a project that is scattered all over the world. From the US to Japan, we have a lot of people using these things, both in terms of research and also in commercial applications by companies of many different kinds. We have a lot of press attention from Wired, TechCrunch. We have a lot of people talking good about the things we're doing. Some of them we don't really know what they're saying, but we think it's good things that they are recommending. And so we have a limited number of units that you can use for your hacks during these days, and I would invite you to grab some of those units and do some cool projects over these days, okay? Thanks a lot.
All right, thanks a lot, Hugo. And here we have Rebecca and Mick from Goldsmiths University, who are going to present several technologies that they will have in here. So,
Thanks. Can we get the other laptop showing up on the monitor? I'm going to project from that one. Yeah. Yeah, we're plugged in. Hi, everybody. I'm Rebecca. We've got a few technologies that we're actually going to show you in a live demo today. So the stuff that we're going to show you is really made for hackers like you who want to build new, expressive, interactive systems really quickly, who also want to build things that are accurate, robust, fast, and work on mobile devices if you want. So we're going to show you a demo which does two things. First of all, we're getting data from a smartphone using just the TouchOSC app on Mick's phone, and we are going to, on this stage in about 60 seconds, build a complete instrument that uses a smartphone to control an audiovisual sketch in open frameworks. And we're going to use the Wekinator toolkit to do this. The Wekinator takes in open sound control data from anywhere. This could be from Bitalino, from a phone, from a webcam analysis, from whatever you want, sensors, Arduino, and it allows you to build a mapping from that data to control anything else via open sound control, Max, PD, Ableton for live, Max for live, anything. So what Mick is doing here right now is setting up a new Wekinator project. Hopefully you guys can all see this. I quit that one. And we're going to send information from his phone through a set of machine learning models and use it to control an open framework sketch which uses Maximilian, which is another one of our technologies. There's our Maximilian sketch. This is an open frameworks add-on. So this is doing some real-time audio synthesis, but also real-time audio analysis and using spectral analysis of the sound to drive this animation. And so what we're going to do right now is Mick is going to set the sketch to a combination of sound and image that he likes. And we're going to use Wekinator to demonstrate, all right, this is a gesture with the phone that we want to be paired with this sound. So go for it. All right. And now we're going to pick a different sound and show Wekinator another type of example. Say this is a different gesture and we want this gesture to make that sound. So he's done that. And now we're going to train a machine learning system and run it. And now we've got a new instrument. All right, so that's our demo. If you could switch back to the other laptop, we have a website, wekinator.org, WEKINATOR. I'll put this up for you. If you go to this website, you'll be able to download examples for lots and lots of different music programming languages, hooking them up with different kinds of sensors, the Wekinator software, the Maximilian software, and also Gesture Variation Follower, which is another machine learning toolkit for doing gestural control and analysis. So go to wekinator.org, just download all the stuff there for your operating system. Mick and I will be around all day today and tomorrow, and if you want a tutorial, we're happy to sit down with you and show you how it works.
Thank you, guys. So, yeah, an applause. Now is the turn of Bird Conductive. So we have Matt here, so you can come and set up your stuff. Thank you. We have an adapter there. Yeah. I have your adapter.
Thank you. Perfect. So you should tell me when you want to switch to the other.
Okay, cool.
When you tell me, we switch.
Okay, thanks. Hello. I know everybody's now totally focused on hacking, but you should pay attention to this guy in the pink t-shirt. I'll swear if everybody pays attention. I'm not fucking kidding. Yeah, exactly. Okay, so anyway, I'm going to be super, super short so we can all get on to what we want to do. I think we're here to liberate interaction away from the screen and away from the keyboard. What we do is we make two things. We make an electrically conductive paint. So it's a paint that you can put on pretty much anything and it conducts electricity. And then we make a really cool piece of capacitive touch hardware that's based on an Arduino that allows you to turn that paint into a sensor. So paint it on anything you want and turn that into an interface. So you could do something like this really crappy example I told you I would swear, which is a keyboard that's painted, you touch it, it controls GarageBand and an iPad. It is quite cool that you can connect to an iPad with it. So we've got code for that. We can sort you out. It's really straightforward. You can use it with proximity, as I'll show you in a second. So you actually don't have to touch the paint in order to interact with it. But this also means that you can hide it behind something. So if you wanted to paint it on the other side of a piece of glass, you could still interact with the sensor. And the sensor gives you a gradient of outputs, right? So it's not just a discrete thing, right? You can map your proximity, which is pretty wicked. So you can connect anything conductive to the sensor, right? That could be some of our paint. It could be a piece of copper, a piece of foil, pots and pans. It does work with fruit, anything like that, right? You don't even have to, you don't have to calibrate for the different materials. It's very straightforward. Because it's based on an Arduino and it has the Arduino shield pattern, what that means is you can stack whatever you want on top to change the functionality. Super straightforward. We have lots and lots of code for you today. As I said, it's myself and my colleague Stefan. I'm wearing the big pink t-shirt. I'm an American guy, I swear. You can come find me. I can help you out. What we want to do is see everybody here as much as possible connecting lots of weird stuff from the real world into their digital devices to create these interfaces. And that's it. And now, if you could please switch my screen, and I'll try and wake my computer up. So hopefully everybody can see that we've got this max patch running. All I'm doing is mapping USB MIDI from the touch board. Yeah? Okay, no signals. It's okay. Yeah, angle it up. Okay, this is my lovely assistant. So as a backup, we've got some lights on top of the board. Now you can see that actually I don't even need to touch the sensor, right? So you can get reliable proximity sensing from, I don't know, about this far away. So any intermediate material will work. Guys, don't worry about sorting it out. It's fine. I don't want to take the next person's space. Basically, come and find me. We've got lots of boards. We've got lots of code. We have lots of paints, lots of crap in our box. So we're happy to work with you. That's it. I'll give it over to the next guy. Okay, now it's working. You know I'm not lying. That's it. I'm done.
All right. Okay, so thanks to the guys from Very Conductive, and now we have the guys from Epson with the Moverio glasses, right? So here you go.
Hello, everyone. This is a Moverio glasses. The particularity of these glasses is to see the world with two glasses in augmented reality. Augmented reality today is with a phone, with a tablet, but with a Movito glasses is not the same. Sorry. My English is Indian English. The specs, the technical specs you see in the display, Android, GPS, cam, gyroscope, Miracast, Bluetooth. Okay. To control the camera, it's important to see these specs, the frame rate, the zen mode, the sharpness, and white balance. To working with a 3D contents, it's important to see these specs. And disable the sensors. Disable the sensor with the pad. Moverio has a Dolby Digital Plus. Okay. This is my short presentation with Moverio, sorry. Thank you.
Okay. So yeah, thanks to Epson. Now we have Yuaki Kukawa from No New Folk Studio who will talk about, will show Orf, the augmented shoes. So.
Thank you.
Okay, you'll have to tell me broadly. Well, let me first. Can you put your keynote document? Put your document.
So maybe document is.
How do you go to system preferences?
Okay.
Displays. ¿Sí? Ya, pero no veies que, clar, això és japonès, ja és un nivell, diguem.
No, però això és conèixer el sistema tan bé que és igual
Bueno,
que estigui que...
Ja volia buscar system preferences. Is this normal that it takes that long?
No. Maybe it's working the other display. In other display, there.
Okay, no. No, it's that one in the middle, and then this one. No, this one.
This one. But I'd like to use
Extended?
separate.
Oh, you want the extended? Wow.
No, that's red, right?
Baile de colores.
Sí, però això és calibració de monitor.
Ja.
Can you show the display?
That should be working. Can you play the document and see?
I can't see the display. Wait a second, let me... No!
Espera, potser el pots portar aquí al keynote, no? Amb el...
No, és que això hi ha una manera de dir-li que aquesta t'està treballant com a secundària.
Ja, el problema és que no li pot posar play perquè no ho veu, saps? No sap tampoc on és. Saps? No s'hi pot arrossegar aquí la finestra.
Clar, sense veure-ho.
Yeah, I know.
Yeah, sure.
But
No,
this is
it's
a file.
right.
No, mira, saps què pots ficar l'altre sigla principal.
Sí, és el que volia...
Sí, sí, això sí que ho podem fer.
Però igualment va...
Sí, sí.
Va ser el primer que no, Si el té, parla bé.
Ai, Déu meu. Estava veient que em passés el d'allò, però no me l'ha passat.
Excuse me, maybe I can do it. Just show seeing the push.
No, we want to change the main screen over here.
No, it's no problem. Yesterday I did it successfully and just push the lamp.
Just right for a second. Okay. Okay,
Okay.
now play. I si es veu al revés, fas el... Okay.
Thank you so much. Yeah. Hi, encantado. Now we'd like to show you about Orphe, smart shoes system for artists and performers. Nice to meet you. I'm Yuya Kikukawa. I'm a PhD student of Graduate School of Tokyo Metropolitan University, and I was visiting University Pompei Fabula during summer of 2015. And now I'm a CEO and a founder of No New Focus Studio from 2015 winter. Okay, I'm interested in interface design and sound interaction design. Last year, I made a prototype of shoe instrument. It has a pressure sensors that are laid in the sole and microcontrollers and the sensors vary to the computer wirelessly. The computer analyzes the peak of the pressure and detects the step of the users, and it generates the sound and sends a message to trigger of the shoe and LED flash. I brought this prototype at Music Hack Day Barcelona 2014 and collaborated with the two Dutch hackers to create one performance. It was called Braquilarios, and it was received the prize of the Spanish Ministry of Industry, prize of Sonar Plus D, and Excellence Innovation Award. So in this performance, we are integrating interactive shoe and muscle recognition and LED performance. After this experience, I noticed the possibility of shoe instrument. At the same time, the interactive lighting effect is very impressive for audience. Also, simple LED shoes are already exist in the market. There are no interactive ones. Then I came up with the concept of Orphe. And this is a movie of Orphe.
Orphe is a smart shoe system for artists and performers. The sole of each shoe contains almost 100 serially controlled LED lights, cutting-edge motion sensors, a Bluetooth module, and an ARM Cortex-M3 processor. Finding a way to make shoes that have batteries and a host of electronic components inside them has been very challenging, but through close collaboration between a shoemaker and our engineers, we've been able to achieve a design that functions well as both an interface and practical footwear. The high-density, full-color LED lights embedded in the specially formed Orphe soles can each be controlled independently, allowing users to create unique, customizable lighting patterns.
ユーザーはスマートフォンやタブレットを通じて簡単に光のパターンをアサインすることができます。また、明るさや色を運動に応じて制御することができます。
Each Orphe shoe captures the movements of your foot and can send this motion data to an external device or application in real time using its onboard Bluetooth module.
それによって例えば、自分のダンスに同期した音楽演奏をしたり、もしくは自分のモーションによって映像の演出を操作するようなことができます。どのようなパフォーマンスやアプリケーションを作っていくかというのは、この靴に興味を持っていただいた皆さんと一緒にさらに拡張していきたいと考えています。
We provide a service that lets users share the lighting patterns, sounds, and interactions they've created online. Through this service, you can download other users' designs or practice dancing along with their gestures. We've also released a software development kit, so anyone can develop their own applications that make use of the Orphe hardware. We've prepared a framework that makes it easy to control Orphe's inputs and outputs. And using our open source tools, anyone can create and release applications for our system. Orphe connects various genres of creativity, from dance, music, engineering, and fashion to everyday life. We are excited to work with artists and innovators from all over the world to develop and expand this creative platform.
Okay, thank you. We did a crowdfunding campaign on Indiegogo, and we successfully reached $30,000 our goal, and now the funding is over 60,000 goals. And now original funding campaign is finished, but still you can fund our campaign and get Orphe system kit before it's on sale. And okay, this. Okay. Today, we provide shoes prototype set, and any hackers can hack the Orphe factory worldwide. And we also provide a Pure Data IO API, and it is very intuitive and very easy. So, and we can provide manual and technical support. Pure Data IO API is very simple, so maybe almost hacker can control it immediately. And to the most talented hacker, we will give the Orphe Innovation Prize. We will give Orphe System Kit in December 2015. Then you will be the first user of Orphe. And you can be a special Orphe hacker, and we will support you to make new application for Orphe. So please come to us and please ask about Orphe. Okay, thank you so much.
Thank you, Juja. And now we are moving to StarLab. It's going to present the Enovio.
Hello, good morning, everybody. Hello, my name is Aureli Soria Frisch. I'm coming from StarLab. I would like to show you some features of Enovio. Enovio is a wearable device which is able to measure your brain, your heart, and your movements, since it has some accelerators integrated in the same device. And we have improved a lot our interface with the device, so we are providing streamings in TCP and OSC for you to develop your music applications. So you basically place it like this, and it's wireless connected to the computer, so everything is streamed wireless to the central computer where you can develop your application. A bit of background, what can you do there? Basically, in your body, there are several electrical signals. For instance, all neurons in your brain are communicating with each other through electrical impulses. And what Enovio is doing is capturing these electrical signals either from the brain, from the muscles, or from the heart, translating them into digital signals, and then we are providing the functionality for you to work with more numerical features like balance, arousal, relaxation, heartbeat, some movements of the accelerators. This is all the information you can get from the Enovio. So I And the idea, for instance, if you are getting balance and arousal, is that you can represent any kind of complex emotional state based on these two measurements, the balance and the arousal, and therefore sonify them or control any kind of music events that you have designed. So these are the two main purposes of the device. So you can control playing events, or you can sonify the electrical signals themselves. How to do it? We are providing basically different applications that are able to stream them in TCP, and then standalone applications or PD patches that stream them in OSC. I will go a bit more in detail over them. The first one is called the NE feature extractor. Basically, this is streaming numerical values over TCP. Numerical values that are associated with different brain features like workload, relaxation, or muscle movements. Or you can, if you are very courageous, you can get access to the raw data and try to process it yourself. What you are getting over the TCP stream is basically an ASCII string, what you can further process. One interesting feature of this standalone application is that you are able to read files to develop your application offline, so you can always work with the same data set, and later on you can connect the Enovio in order to do the same with the real live streaming. The other application is so-called brain polyphony. The main difference is that you are getting here brain features, but also heart features and movement features, all normalized in a range between -1 and 1, so it's very convenient for further processing. You are getting also the TCP stream in ASCII format. You can find more information on the wiki of the Music Hack Day on the website. If you don't want to work with a TCP stream, but with an OSC one, we are providing as well a standalone application that it's connecting to the TCP port of either the feature extractor or the brain polyphony, and streaming it further in OSC format, so that you can read it from any of your application of choice or your framework of choice for further developing the application. You would have also a PD patch that it's able to read the TCP and translate it into an OSC stream, so that you can directly work in PD with the signals, for instance, with the normalized signals of the brain polyphony. And then we are providing in the wiki as well some examples of how to integrate the Enovio with processing framework. And we are proposing a challenge for you to solve. This is mainly to translate your emotional states or the emotional states of any subject into music. And the idea is that we can use what you are doing, if you like, within a project where we are developing such a system for patients, for cerebral palsy patients. This is a kind of disability, that communication disability that doesn't allow the patients to communicate regularly. So the idea is that you can, through the music that is generated from the brain and body, you can communicate the emotional state of the patient. You can also develop BCI applications if you want, but ask for more information to the Starlab team that is sitting there in this first column of tables at the end. And these are our photographs and myself. We would be very happy to help you with your application development. And thank you very much for your attention.
All right, so thanks a lot to Starlab. And now we have, well, Specs UPF with Teatronica, right? And Martí, so here you go.
Thank you very much. We are Teatronica from Universidad Pompeu Fabra, Specs Lab. We brought to the Music Hack Day two robots, two now robots. We are using these robots to link robotics and arts, performing arts, okay? So for you today in the Music Hack Day, we are working on a MIDI to robot movement interface with MaxMSP that we have available in our GitHub that you can find in the webpage of the project. Then we want to use the robot joints as music controllers because the joints of the robot are linked together. They can be an interesting way of touching different parameters at the same time and see what happens. Being able to control up to 7 degrees of freedom at the same time in each arm with a very simple movement. So we are going to try that as well. So both directions. And of course, if you want to have the robot for your performance, you can talk to us and we can try to also add some movement into it. And we will try also to prepare a short performance for you. So the Now robot, it's a commercial robot. It's from a company called Aldebaran in France. We have OSC protocol, very simple, to access all the joints of the robot, and then to also control the joints of the robot. We have a processing GUI, and then we also have this MaxMSP control. Let's see now if the robot presents ourselves to you, and I will finish with the
day. Teatronica joins robotics and performing arts.
Something more?
For you in Sonar, we are going to perform some music. We are ready and at your service for Sonar. You got the power.
Okay, guys, thank you very much. This is all.
Okay, so thanks a lot, Martí. And now we have the final presentation by Fab Lab Barcelona and Anastasia Pistofidou. ¿Qué pasa? ¿Se ve algo en la pantalla?
Do you want to do the
I can do the
makerspace. I don't have any slides, so I'm just
Ah, for the pop-up lab.
Yeah, so I can start talking now while they're setting
Okay.
that.
All right, so let's start talking about the pop-up lab while they are setting up the computer, okay? So here you go.
Hi there. I'm Dave. I'm from the Made Makerspace in Barcelona. And this is the second year we're providing some rapid prototyping production services for the Music Hack Day. So over here we have various equipment, laser cutters, 3D printers, sewing machines, soldering stations. The makerspace that I'm part of is reasonably close by. So if there's any particular piece of equipment that you think you may need, feel free to come and ask, and I will, if we have one, I will certainly see if we can bring it over and get it in use. But that's pretty much it. One of the things about last year was there was a tomorrow morning rush, as people, of course, all decided at the last minute that they would like to get something manufactured. So I would suggest maybe thinking ahead if you have some production requirements, because certainly some of the 3D printing stuff can take a while. And also on the 3D printing, if you have a look in Thingiverse, there's a reasonably good chance you'll find a model already existing fairly close to what you want, whether that is kind of a bracelet or a necklace or a ring. Those sort of things for wearables are relatively straightforward to download and print. So I look forward to meeting as many as I can over the next couple of days and come by and have a word. Thanks.
Yeah, thanks. This is Fabula Barcelona in collaboration with Made Makerspace. You can have access to tools. We can help you integrate and make embedded systems of your electronics. We have soldering stations. We have some sensors, Raspberry Pis, lily pads, conductive threads, 3D printers, laser cutters, material, textiles. We can sew. We can make a nice wearable prototype. The challenge for us is to get more and more into integrated and embedded systems. And probably the winner of our challenge can have some kind of artistic residency in the Fab Lab. And also they want to say something. We have been working a lot into wearables, and we have, you can also find codes on our Wikipedia and on our GitHub Fab Lab BCN about capacity sensoring and amplifier. But also we have an experimentation line which is called Fab Textiles, which is a lot into how we can relate the body with electronics and integrate digital fabrication into fashion.
Sorry, and I kind of forgot the most important thing there, which is we also have a prize for one of the teams, which I think we're basing on the best performance in the final selection. In this year's Maker Fair in Barcelona, which happens in September, I'm hoping to be organizing a maker music stage for the first time. And we would like to offer the winner of our performance competition a slot on that maker space at the Barcelona Maker Fair later in the year. So hopefully that's attractive to a few of you.
So we are here, whatever you need. If you need to make some kind of clothing, if you need to make some boxing or anything, we can design it for you. We can help you design it, whatever you need. Thank you.
So guys, this is the end of the presentation of tools. So remember that as we have the maker space here, if you are thinking of like prototyping a wearable interface and you have to print out like some sort of case or something for your sensors, you have it on your disposal. So
I don't know. I mean, so now we have lunch. We have some dead space until 1 o'clock. At 1 o'clock we have lunch. At 2 o'clock the official kickoff of the hack day begins. So yeah, I don't know. See you around and see you for lunch at 1 o'clock.
Challenges?
And the challenges?
Yeah, and just after the kickoff of the hackathon, we are going to make a short presentation of the challenges, so you know, I mean, what's on stake and what's the prices and so on. So that's it. We have lunch in 15 minutes.